So for today's video lesson, we're going to jump into the derivative rules. Okay, there are going to be a few. I think there's like 6 or 7. So we will take our time as we get through those. Today we're going to get to the power rule, the derivative of a constant times a function, and then also the sum and difference rule. Okay, so they're pretty basic. And it's going to make our lives a lot easier when we're trying to solve these questions. Okay, so instead of using first principles, to determine our derivatives every time, mathematicians have developed a series of derivative rules that will simplify the process of differentiating a function. Okay, so here we're given 6 functions, and we're also given the derivatives of each function. Okay, so using our derivatives and solving them using first principles, we have seen that if our function or f of x is x squared, then our f prime of x will be 2x. Okay, there should be a 2 there. And again, we're going to talk about the power rule soon enough, okay? So I just want you to look at these 6 functions here and just kind of see the pattern here. So let's take some time to look at those. So maybe the one that I had to correct may have given away the pattern, but as what we're doing, we're taking the exponent, bringing it out front of the number, and then we are subtracting 1 from that exponent, right? So if our f of x is x squared, f prime of x, or the derivative of that would be 2x. Okay, so if f of x is x cubed, the derivative or f prime of x would be 3x squared. For f of x, we have 2x cubed. F prime of x would be 6x. Okay, and so on and so forth. So we do see a pattern, and this is going to be considered the power rule. Okay, so hopefully you guys are able to see a pattern there. So the power rule, so for y is equal to x to the n, the derivative of y with respect to x is equal to n times x to the exponent n minus 1. Okay, this will be true for all real values of n. Okay, so sometimes, like today, we're going to go into some examples where n is negative, okay? And that's going to be okay, because we can still use the power rule when we have negative exponents. Okay, so the exponent n of the original function appears as the coefficient of the derivative. And the exponent of the derivative is 1 less than the exponent of the original function. Okay, so that is basically just kind of paraphrasing or putting into words what is actually happening for the power rule up here. I keep pointing at the whiteboard, expecting you guys are here to look at it, and then I realize that you only see what I write on the smartboard, so I laugh at myself. Okay, so this is the power rule in a nutshell. So let's go through these examples using our power rule. Okay, so if y is equal to x to the -1, so the derivative of y with respect to x, so we're going to bring that -1 out front of that x. So a -1, and then we, as our exponent is already -1, but then we're going to subtract 1 more. Okay, so we can rewrite that as -1. -1 subtract 1 more will be -2. Okay, and don't let me forget the x here. So that exponent belongs to the x. Okay, I'm just moving over. Okay, we can simplify this a little bit. We'll just get rid of that -1. So we'll have -x to the exponent -2. Okay, and we don't like negative exponents, so we can rewrite this as -1 over x squared. Okay, fair enough, easy enough. So let's continue. So we have y is equal to x to the 4. So y prime or derivative of y prime or derivative of y with respect to x. So same thing, we're just going to take that exponent, put it out front, and then subtract 1 from that exponent. So we'll have 4x, and we're subtracting 1 from that 4. So it'll be 4x cubed. That's it. Nice and easy. Nice and short, okay? We like the power rule. So this one here, f of x is equal to the square root of x. So we got to think of our exponent rules here. So we can rewrite this one. If it's the square root of x, we could rewrite that as x to the exponent 1 over 2. Okay, so that is, we just rewrote our f of x function there. So f prime of x will be, so same thing, we're just going to put that 1/2 coefficient in the front. And then we are subtracting 1 from that 1/2. So 1/2 subtract 1 will be -1 over 2. Okay, and we can rewrite this because that kind of looks ugly with all those fractions. So it'll be 1 over 2 x to the 1 over 2. And we don't like our exponents to have fractions, so we can rewrite that again. 1 over 2 times root x. Okay, so for this last example here, we have y is equal to 1 over x to the 4. Excuse me. Okay, so we can rewrite this. So y is equal to x to the -4. And same thing, we're just going to take that exponent, put it out front, and subtract 1 from that exponent. So that's y, so this is going to be y prime. So y prime will just be the derivative of y. And then we'll have -4x, -4 subtract 1 is -5. Okay, we can rewrite this as -4 over x to the 5.
Hey, Mr. Jones.
Yes.
For the one above, do we have to rationalize the denominator?
No, not in this case, because we're just finding the derivative of it. If I said find the derivative and rationalize the denominator, then you would have to. But as is there, that's fine because we're just looking for the derivative.
Okay,
Good question.
that was Annabelle, not me.
Oh, sorry, Annabelle. Good question. Sorry, if you guys like make comments in the chat, I just can't see it while I'm up here. I'm not looking at it. So sorry that I can't see that. But good question, Annabelle. Okay, so this is the power rule. Do we like the power rule?
Yes.
I'm a big fan of the power rule. I remember the first time that I learned derivatives. And of course, like you always learn the first principles first, and then they show you the power rule. I'm like, why don't we just start with the power rule? I don't understand. But now you know the math behind it. Okay, so are there any questions with these 4 examples? Perfect. Let's continue. Okay, so rule number 2. So this is when we're finding the derivative when we have a constant multiplied by our function. Okay, so if our original function y is equal to c times f of x, the derivative of y with respect to x, so I'm just going to throw in some brackets here. So we will have the constant will be removed from that, and then we're going to multiply that by the derivative of f of x with respect to x. Okay, so we do not take the derivative of a constant or any real number. Okay, so c will represent the vertical stretch on a function, and the slope of the tangent, so the derivative of that point, will experience the same stretch. All right. So let's go through a few more examples. So we have f of x is equal to 3x to the exponent negative 1/3. So f prime of x is equal to 3 multiplied by the derivative of x in there. Okay, so same thing, we'll take that negative 1/3, put it out in front. And then if we subtract 1 from 1/3, from negative 1/3, we will get negative 4/3. Okay, so at this point here, now that we have taken the derivative of x, now we can simplify this. So we can distribute this inside. So 3 times negative 1/3 will equal negative 1. X to the exponent negative 4/3. Okay, so we can rewrite this as negative 1 over x to the 4/3. And this can be rewritten as negative 1 over the cubed root of x to the 4. Okay, so when we have a fraction in the exponent, the denominator of that fraction is going to be whatever root that you're taking of x, and the numerator of that will be the exponent on x. So x to the 4/3 can be rewritten as the cubed root of x to the 4. Okay, so we gotta be familiar with our exponent rules here. Okay, so this one here, same thing, same idea. We'll take the 5 out of that. So y prime is equal to 5 multiplied by the derivative of x. So that is going to be, we'll take the 4 out front. So 4x cubed. Okay, now that we've taken the derivative of that, we can put those together. So 5 times 4x cubed will equal 20x cubed. Okay, and for our last one here, same thing. So we'll take that constant outside of that, and then we will take the square root, and then we will apply the power rule to this x, for lack of a better term. Okay, so x to the square root is, so I'm just going to rewrite this as negative 3x to the 1 over 2. Okay, so if we take the derivative of that, we'll have 1 over 2 coming out front. Okay, I don't want to forget my negative there, sorry. Then we'll put the 1 over half in front. We will subtract 1 from 1/2. So we will get negative 1 over 2. Okay, we can multiply this in now. So 3 times 1 over 2 is equal to negative 3 over 2. X to the exponent negative 1 over 2. So we can rewrite this. That's negative 3 over 2x to the 1/2. And we need to recognize that x to the 1/2 is the same as taking the square root of x. And there we go. Are there any questions so far? Perfect. Am I going too fast, or are we going at a good pace here?
Golden.
Golden, I like that. Okay, rule number 3 for today, and this is going to be the last rule that we will introduce. So the sum and the difference rule. So for y is equal to f of x plus or minus g of x, it will just be the derivative of f of x with respect to x plus or minus the derivative of g of x with respect to x. So when we're differentiating a function with the sum or the difference of more than one term, just find the derivative of each term separately and keep the sign. Okay. So fair enough, seems pretty straightforward, I think. So let's say this is f of x. Okay, so we'll find f prime of x. So if we are going to find the derivative of 3x to the 4, so it will take 3 outside of it, and then we will apply the power rule to our x. So bring the 4 out in front, 4x, and then 4 minus 1 is equal to 3. Okay. Then we can leave that one. Okay. Now we have subtract. So 2 will be outside. And then we'll apply the power rule again. So x to the cubed, we'll put the 3 out in front, x, and then 2. So next one we're going to be adding. So we'll take the 5 out front, and then we will do apply the power rule. So 2x, 2 minus 1 is 1. So I'm going to exclude the exponent on there. Okay, and then we're subtracting x. So the derivative, okay, so we have an exponent of x to the 1 there. So we can bring out the -1, and then x to the 0 is going to be 1. Right? Anything to the exponent of 0 is equal to 1. And then we will do the last one, so 7. And so for this one, let's pretend we have an x to the 0 here. Okay, so if we bring out that 0 in front, it is just going to make it a 0. So that will go away. So if you're like, anytime that you have just a number on its own, the derivative of that is going to be 0, okay? Put a mental note there, just make sure that you know that. Okay, so now that we're at this point, we can just simplify here. So distribute our 3 in, so we'll have 12x cubed, subtract 6x squared, plus 10x minus 1. Okay. All right. So for this next one, we'll just continue to do the same thing. So f prime of x is equal to, we'll take out the half. X to the 6 will be 6x to the 5 minus 6. X to the squared will, x squared will become 2x. And the derivative of just a number is going to be 0. Okay, so now we can distribute in, or simplify this. So 1 over 2 times 6 will be 3x to the 5 minus 12x. How are we feeling? Pretty good? Good, good. Okay, so if f of x is equal to c, so what is the exponent of x? We kind of just touched on this. So c times x to the 0. So f prime of x will be c times 0x, 0 minus 1. So is this going to equal 0? If you're taking f prime, if you're taking the derivative of a constant. So just note that the exponent of x is x to the 0. Okay. If f of x is equal to cx plus d. So if there is only a one exponent on that x, then just the derivative of that function is going to be c. Okay, so let's go in and let's apply what we've learned today. So we're going to find the equations of the tangent and the normal to f of x is equal to x cubed. And we are really concerned with the point that x is equal to 2. Okay, so if f of x is equal to x cubed, we can apply the power rule to find f prime of x quickly. So that will be 3x squared. Okay, so this is our slope of the tangent, general to our function f of x. Okay, we are concerned at x is equal to, so we will substitute that in. So the slope, so we've just found the general slope here. Okay, and now we want to find the slope at x is equal to 2. So we will just substitute that into our derivative, our f prime of x expression. So so the slope at this point, we'll just substitute in x for 2. And if we do that, 2 squared is 4 times 3, so we will get m is equal to 12. So this is the slope of our tangent at x is equal to 2. Okay, so I just wanted to do a little refresher. I'll write our 3 steps for when we are finding equations. So 1, we're going to want to find the slope. 2, we want to find b, which is the y-intercept. And then lastly, we will write our equation. In standard form. Okay, so we have found the slope. Now we need to find b. So we need a point. So let's substitute in x is equal to 2 for x cubed. So f of 2 is equal to 2 to the cubed, which is equal to 8. Therefore, we have a point at 2 and 8. Okay, so this was step 1. Find the slope. Step 2, we will find b. So that is our general equation for a line. So y is equal to mx plus b. So we know that y is 8. Our slope is 12. Our x is 2. And we can solve for b. So 12 times 2 is 24. So subtract 24 from both sides. 8 subtract 24 is equal to negative 16. And that is equal to b. Okay, for step 3, our equation. So we know m is 12 and b is negative 16. So y is equal to 12x minus 16. And when we write it in standard form, we want to get it all on one side of the equation and have a positive coefficient in front of x. So let's subtract y from both sides. Okay, so that is the equation of our tangent line at x is equal to 2. Okay, so lastly, we need to find the equation for the normal line. Does anybody remember the relationship of the normal line to the tangent line? So it is the negative inverse of the slope of the tangent. Okay, so if our slope of our tangent is 12, then the slope of our normal is going to be negative 1 over 12. Okay, so now we will solve for b again. So y is 8, m is negative 1 over 12, x is 2, and b is b. Okay, so we can simplify this. So 2 multiplied by 1 over 12 is equal to negative 1 over 6 plus b. So if we add 1 over 6 to both sides, that will cancel. Now remember, 8 as a fraction is 48 over 6. So if we add 1 to that, we will get 49 over 6 is equal to b. So now that we know b and we know m, we can find the equation of our line. So y is equal to negative 112x plus 49 over 6. Okay, I am going to multiply this by 12. Get rid of that denominator. So I'll be left with 12y is equal to negative x plus, so 49 over 6 multiplied by 12 is equal to 98. And remember, we want positive coefficients for x. So let's add this to both sides and subtract 98. That will cancel. So then we'll be left with 0 is equal to x plus 12y minus 98. All good? Cool. All right. So now we can solve for some of the questions where we're given the slope of the normal line. Okay, we're going to determine the point on the graph on y is equal to x squared. So remember that is a parabola. And we're looking for where the normal has a slope of 1/2. Okay, so remember we said that the normal slope was the negative inverse of the tangent line. So if the slope of the normal is 1/2, therefore the slope of the tangent is equal to -2. Okay, so therefore y prime is equal to -2. Okay, so if we have, okay, so y is equal to x squared is our original function. Now, in this case, if we find y prime of that using our power rule, we will get 2x. Now, why does the y prime and when we find the y prime of x squared and we find the y prime using the slope of our tangent, we get different values, okay? But actually we can, because we know that y prime is -2, the slope of our tangent, we can actually substitute this value into this because we know y prime is equal to -2. So at that point, we know y prime is -2. So -2 is equal to 2x. Now we can isolate for x, so divide by 2 on both sides. -2 divided by 2 is equal to -1. So x is equal to -1. So what did we just do there? So first off, we found the slope of the tangent using the slope of the normal line and just our knowledge of the relationship between the normal line and the slope of the tangent. We found y prime. We found the derivative of our function y is equal to x squared. And we know the slope at that particular place. So we substituted in our y primes, okay? When we did that, we were able to isolate the point, the x coordinate of the point where the normal has a slope of 1/2. So if we know our x coordinate, we can find our y coordinate. So y of -1 is equal to -1 squared. So y of -1 is equal to 1. Therefore, our point will be -1 and 1. So we can summarize that, and then we can say the normal line has a slope of 1/2 when x is equal to -1 at the point -1. Okay. We have one more question to go through. So Hopefully your gym class can wait a few minutes, or your option class. And if not, that's okay. Just catch this last question on the YouTube video. Okay, this is just a short one. It shouldn't take us very long. Okay, are there any questions on this question before I go ahead? You're all just like, let us go, Mr. Jones. Come on, the bell rang. We heard it. I know, I heard it too. Okay, so this guy here, we're going to find the slope of the tangent to f of x. So our function is 3x squared minus 5x plus 4 at x is equal to 4. So let's find f prime of x using our power rule, the derivative of a constant times the function, and the sum and difference rule. Okay, so f prime of x. So we will bring the 3 outside. The derivative of x squared will just be 2x minus 5. The derivative of any number that is attached to the x, remember, will just be the number. Okay. I was going to put a 1 in there because x to the 0 is 1, but it's the same thing. Okay, and then the derivative of a number is just going to be 0. Okay, so we can simplify this. So 6x minus 5 is f prime of x. So there is the general slope of our tangent. Now we are interested in the slope of the tangent at x equals 4. So f prime of 4 is equal to 6 times 4 minus 5. So 6 times 4 is 24, minus 5 is equal to 19. So the slope at x is equal to 4 is 19. All right, so here are your questions that are for homework. I will give you tomorrow's class time to complete that. So if you have any questions as you solve those, send me a text or an email. I'd be happy to help you. Okay, thank you for tuning in, and I'll talk to you later.